Alright, so today we're looking at the investigative task from the 2017 exam. Here we go. Consider an experiment in which two men and two women will be randomly assigned to either a treatment group or a control group in such a way that each group has two people. The people are identified as man 1, man 2, woman 1, and woman 2. The 6 possible arrangements are shown below. Okay. 2 possible methods of assignment are being considered, the sequential coin flip method as described in Part A and the chip method as described in Part B. For each method, the order of the assignment will be man 1, man 2, woman 1, woman 2. So the order in which they're assigned matters. So what that basically means is that man 1, he'll get the coin, he'll flip it. He gets heads, he gets X, he gets tails, he gets Y. Then man 2 will go, and then woman 1 will go. And based off where each lies, the probability of each arrangement is changed. Okay, here we go. Part A. For the sequential coin flip method, a fair coin is flipped until one group has two people. Okay, so that's probably important. A fair coin is flipped until one group has two people. Okay. An outcome of tails assigns the person to the treatment group, and an outcome of heads assigns the person to the control group. So heads becomes control, tails becomes treatment. Okay. As soon as one group has two people, the remaining people are automatically assigned to the other group. Okay. Complete the following by calculating the probability of each arrangement occurring if the sequential coin flip method is used. Okay, well for A, man 1 goes up, he flips a coin. There's a 1 out of 2 chance that it lands tails, and then he gets treatment. So 1 out of 2, so 1/2. And then man 2 goes up, 1 out of 2 chance that it lands treatment. It does, so there he goes. There you go. So for arrangement A, the probability is just 1/4. Now, arrangement B. Man 1 goes up, he flips a coin, he lands treatment 1. Okay, 1/2. Man 2 goes up, he lands heads, and he gets control, and he gets a control group. So now you have one person in both groups, neither of which are totally filled. So now it's woman 1's turn. She goes up, she flips the coin, she gets treatment 1, and again, there was 1 out of 2 chance of her getting tails, so 1/2 again. And now woman 2 will be automatically assigned to the control group for arrangement B. So this is equal to 1/2 times a half times a half. This is 1/8. 1/8. There we go. Now C, man 1 goes up, flips a coin, he lands tails. So again, 1/2 probability, 1 out of 2. Then man 2 is the same situation with B, except woman 1 just gets assigned control rather than treatment. So that's going to be 1/2 times a half times a half, which again is 1/8. Make sure you're as neat as possible with this. Arrangement D, man 1 flips a coin, gets that. Man 2 flips a coin. The same group, so this control is automatically filled. So that means woman 1, woman 2 are then assigned to this group. So now it's the same exact thing that happened in A. It's happening right here. So this is a 4th. Okay, E. Man 1 flips a coin, gets that. Man 2 flips a coin, gets that. The woman 1 gets that, and then she's automatically assigned. So a half times a half times a half is 1/8. And then the same situation. Man 1, man 2, except now woman 1 and woman 2 are swapped. So 1/8 again. And make sure you go back and you actually make sure that these values sum to 1. So I see 4 1/8, so that's a half. And I see 2 1/4, that's another half. A half and a half equals 1. So yes, all these probabilities, they all sum to 1, so we're good. For the sequential coin flip method, what is the probability that man 1 and man 2 are assigned to the same group? That happened 2 times. In arrangement A and arrangement D. So the probability that man 1 and man two are assigned to the same group is just 1/4, and this happens twice, so this is just going to equal 1/2 or 0.5. Okay, we can move on to the next part of the question. 6 arrangements are repeated below. Okay, it's the same exact one as on the other page. For the chip method, so this is the other method. 2 chips are marked treatment, and 2 chips are marked control. Each person selects 1 chip at random without replacement. So the easiest way that I visualize this is to do the following. So for arrangement A, we're going to say A, colon, treatment, control, man 1, man 2, woman 1, woman 2. Okay, here's our T. You know what? We don't even have to do that because actually it's fine. So again, here's our T chart. That's there. And now we're just going to draw out our chips. So there's 4 chips. 2 of them are T. And then 2 of them are control or C. Right? So, so here we go. Man 1 is going to go and he's going to take a chip. He randomly selects the first one, T. So there was a 2 out of 4 chance that he actually selected T. So look, there's 4 possible combinations that he could have. There's 4 possible chips that he could have chosen from, 2 of which are T. So there was a 2 out of 4 chance he selected this one. Now man 2 is gonna go, and he's gonna select the second T. But now here's the thing: there's only 3 possible chips when he went. There was only 3 possible chips, and he chose the one where there was only 1 treatment. So okay, basically like this. There are now 3 possible chips. So that's our denominator. And he chose the one that was not 2/3. So look, he had a 2/3 chance of picking any one of these, and he had a 1/3 chance of picking this. So he got the 1/3 chance. So 2/4 times 1/3 is just 1/6. Okay, now let's look at arrangement B. I'm going to erase this. We have treatment, control, man 1, woman 1, man 2, woman 2. Okay, so it's different from what we just had. So we're gonna do the same exact thing. We're gonna draw out our chips because we already have the table here. We're gonna draw our chips: T, T, C, C. Circle them. Okay. Man 2 has a 2 out of 4 chance of picking a T. Right? There's 4 chips in the bag. Okay, so this is coming from the without replacement. Once one chip is picked, then it's not put back in the pile. So man 1 goes up. He picks this one. So there was a 2 out of 4 chance that he was going to pick a treatment chip, and then man 2 goes up and he picks a control where there was a 2 out of 3 chance he picks the control. And then now it's woman 1's turn, and she has a 1 out of 2 chance of picking either T or C, and she got T. So 2 times 2 is 4. 4 times 3 is 12. Times 2 is 24. 4/24 is just 1/6. Okay, now we're going to do the same thing with C, right? We have T, T, C, C. Man 1 goes, he picks this chip. There was a 2 out of 4 chance that he took a treatment chip. Man 2 goes, and there's a 2 out of 3 chance that he chooses the control chip. Finally, woman 1 goes up, and there is a 1 out of 2 chance that she chooses this chip. So just like before, 4/24 is simply 1/6. Okay. Now arrangement D, we're gonna do the same thing again. T, T, C, C. Man 1 goes up. There's a 2 out of 4 chance that he gets control. The control. There's a 2 out of 4 chance he picks the control. And then it's man 2's turn to go up. And now there's a 2 out of 3 chance that he also picks control. And then woman 1 and woman 2 are going to be randomly or just assigned to the treatment. Because that's what happens. Once one group is filled, the remainder are put in the other group. So this simplifies down to 1/6. 2 times 2 is 4. 4 times 3 is 12. Sorry. Hold on. That's wrong. That is incorrect. Because when man 2 goes to pick this control chip, there was only a 1/3 chance he was going to get this chip, because there was this one, this one, this one. There's two treatment chips and only one control chip, so he had a 1/3 chance of picking this. So this is equal to 2/12, and this simplifies to 1/6. Okay. Now E, we're going to do the same thing. We're going to do T, T, C, C. Man 1 goes, he picks control. 2 out of 4 chance he picks that. Man 2 then goes and picks treatment. So there's a 2/3 chance he gets that, because there are two treatments chips, and there was only one control chip. So we had a 2/3 chance of getting a treatment and only a 1/3 chance of getting control. And then woman 1 goes up, and there's a 1 out of 2 chance she picks either of them, and she picks this one. So 1 out of 2, so that's equal to 4/24, or again 1/6. Now F, simple trick for this. These, again, like before, they all have to sum to 1. So a 6 plus a 6 plus a 6 plus a 6 plus a 6. That's 5/6. 1 minus 5/6 is just 1/6. Okay, good. And if you're confused what I just did, I basically set an equation: 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus x equals 1, because all the probabilities in this set need to sum to 1. All probabilities have to sum to 1. There you go. Okay, now for the chip method, what is the probability that man 1 and man 2 are assigned to the same group? Well, just like before, there was 2 times where that happened. An arrangement A and arrangement D. So the probability of arrangement A occurring is 1/6. The probability of arrangement D occurring is 1/6. So 2 times 1/6 is just 1/3. So 2, you can say 1/6 plus 1/6, or 2 times 1/6, both equal to 1/3. There you go. And now part C. 16 participants consisting of 10 students and 6 teachers at an elementary school will be used for an experiment to determine lunch preference of the school population of students and teachers. As the participants enter the school cafeteria for lunch, they will be randomly assigned to receive one of 2 lunches, so that 8 will receive a salad and 8 will receive a grilled cheese sandwich. The students will enter the cafeteria first, and the teachers will enter next. Which method, the sequential coin flip method or the chip method, should be used to assign the treatments? Justify your choice. Okay, well, how about we look at both probability sets. Here we see 1/4, 1/8, 1/8, 1/4, 1/8, 1/8. Here we see a constant 1/6. So the chip method is going to be, it should be used to assign the treatments, because there is a uniform probability. There is no bias involved. There is no skew to in favor of one meal or the other. So you always want to choose the one that has a uniform probability spread. So for part C, state the the chip method is to be used to assign the treatments because there is a uniform distribution of probabilities, meaning that there is no bias or skew in favor of one arrangement versus another. There you go. And that should be sufficient credit for this investigative task for the 2017 exam.